Welcome to Get Your FRQ On. This question is from 2006, Form B, and it is question 6. In the question stem, we have a car traveling on a straight track over a time interval from 0 to 60 seconds. Velocity is measured in feet per second, and acceleration is measured in feet per second, and these are both continuous functions. We are also provided with a table with different values of t and v of t and a of t at those values. In part A of this question, we are asked about the integral from 30 to 60 of the absolute value of v of t dt, and to explain its meaning with the correct units and to approximate that integral with the trapezoidal sum. So given that v of t is a velocity function, the integral from 30 to 60 of the absolute value of v of t dt represents the total distance traveled by the car in feet from t equals 30 seconds to t equals 60 seconds. The integral from 30 to 60 of the absolute value of v of t dt is the absolute value of 1/2 times 5 times v of 30 plus v of 35 plus 1/2 15 times v of 35 plus v of 50 plus the absolute value of 1/2 times 10 times v of 50 plus v of 60, which is 5/2 times negative 14 minus 10, the absolute value of that, plus the absolute value of 15/2 times negative 10 plus 0, plus the absolute value of 5 times 0 plus 10. That is the absolute value of 5/2 times negative 24 plus the absolute value of 15/2 times negative 10 plus the absolute value of 5 times 10. And all of that, when you add all of those absolute values together, we get 185. So the car traveled 185 feet between t equals 30 and t equals 60 seconds. In part B of this question, we are asked about the integral from 0 to 30 of a of t dt, to explain its meaning with units and to provide the exact value. We are given that a of t is the acceleration of the car, so the integral from 0 to 30 of a of t dt represents the change in the velocity of the car in feet per second from t equals 0 to t equals 30 seconds. The integral from 0 to 30 of a of t dt will just be v of 30 minus v of 0, which is negative 14 minus negative 20, which is positive 6. So from t equals 0 seconds to t equals 30 seconds, the velocity of the car increased 6 feet per second. In part C of this question, we are considering the interval from 0 to 60, and we are asked, must v of t equal negative 5 somewhere on that interval, and to provide a justification for our answer. It's important to note that we are given v of t is a continuous function. Since v of 35 is negative 10 and v of 50 equals 0, and negative 5 is between negative 10 and 0, we can conclude that yes, there must be some time t between 35 and 50 seconds such that v of t is equal to negative 5. And since there must be a value of t between 35 and 50 such that v of t equals negative 5, this implies the existence of such a value between t equals 0 and t equals 60, since the interval from 35 to 50 is within the interval from 0 to 60. In part D of this question, for the same interval from 0 to 60, we are asked if there must be somewhere where a of t is equal to 0, and to justify our answer. And again, we were given that both v of t and a of t are continuous functions. So this will imply that v of t is differentiable, since its derivative, a of t, exists everywhere on its domain by virtue of a of t being continuous. And then note that v of 0 and v of 25 are equivalent and that they're both equal to negative 20. So there is a value of t between 0 and 25 such that a of t equals 0. And since there's a value of t between 0 and 25 for which a of t is equal to 0, this implies there's a value of t between 0 and 60 such that a of t is equal to 0. And it's important to note here that this problem, like the previous one, had us deal with an interval from 0 to 60, but that wasn't the one we actually had to do the calculations on. We sort of had to justify this with that intermediate interval. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.